Now let's move on to the second part of this example. For this second part, I worked this problem and the numbers did not turn out great. And so what I'd like to do is I'd like to modify the problem, and instead of adding 5 pi over 3, I'm going to subtract pi over 4. It's not that the other problem is not doable, I just don't believe it's conducive to, well, let's say it's not a good problem when we're learning how to do these. Okay, so 3 steps. The first thing we're going to do is we're going to draw our, we're going to identify our midline and our top and bottom horizontal lines. And to do that, we'll identify the transformations here. If f of t is sine t, and you rewrite in terms of f of t, you get that this is negative 2 f of 1/2 t minus pi over 4 plus 1. And we always know that we're going to factor out this 1/2, so it's in the form that allows us to write the shift last. So 1/2 t minus, and you have to ask yourself, 1/2 times what is pi over 4? Whatever the answer is what we'll put there for the question mark, and then we have this plus 1. And if you solve for this question mark, then you get that this is pi over 2. And so we'll put minus pi over 2 here. And now notice in this problem you have vertical stretches and vertical shifts along with horizontal stretches and horizontal shifts. And you have to make sure that not only your horizontal transformations are written in the correct form, but your vertical transformations are as well. And in this problem they are. The negative 2 is not multiplying the plus 1, which is what you need in order to list the shifts last with your transformations. Now we'll go ahead and list the vertical transformations. We have a vertical stretch by 2, a vertical reflection about the x-axis, and we have a vertical shift up by 1. If I remember right, yep, we have plus 1 here. So to get our midline, we'll take our old midline, which is y equals 0, stretch by 2, so multiply by 2, reflect about the x-axis, that means multiply by minus 1, and then finally we'll shift up by 1, which gives us a midline of 1. So y equals 1 is the midline. Hopefully you can see why the midline will always just be whatever the vertical shift is, because when you take 0, your old midline, and you stretch or reflect it, it doesn't do anything to the old midline because anything times 0 is 0. Then to get the top and bottom lines, we'll take the old top and bottom lines, which was y equals 1 and negative 1, and do the same thing. We'll stretch by 2, we'll multiply by minus 1, and then we'll add 1, and that will give us a value of, let's see, negative 2 plus 1 is negative 1, and then we'll multiply here by 2 and negative 1 plus 1, and we get a value of positive 3. So y equals negative 1 and y equals 3 are the top and bottom lines. Another way that you can do this, if you identify what the amplitude is equal to 2, because that is what the vertical stretch is. And so once you have the amplitude and you also have the midline is always equal to the shift. So the midline would be y equals 1. You can find the top and bottom lines by adding and subtracting the amplitude from the midline. So the top slash bottom lines would be y equals 1 plus 2, which is 3, and y equals 1 minus 2, which is negative 1. So we get the same answer, and we'll go ahead and plot our midline, and we'll plot our top and bottom lines. I think as a y scaling here, I'll use this to be 1, so that would be, I don't think that's quite enough. This would be 2, this would be 3, and this would be negative 1. I actually think I have to go a little bit further down to get to negative 1. There we go. Then we can draw our top, our bottom, and our midline. I think I can get a little bit better for my midline, so there we go, and we'll erase this other one. And now I'm ready to determine the t-coordinates, those 5 important t-coordinates. So that's the second step that we'll do. We'll identify what the horizontal transformations are. So we look back here and we see we have a horizontal stretch by a factor of 2 and then a right shift by pi over 2. So horizontal stretch by a factor of 2. And we have a horizontal shift right by pi over 2. So I'll take my first and fifth t-coordinate of my parent function and I'll apply those transformations. So the first important t-coordinate, that will be the transformation of the t-coordinate 0. So 0 times. We have a horizontal stretch by 2, and then we'll shift right by pi over 2. And so this will just be pi over 2. And then the fifth important t-coordinate will be doing the exact same thing, but shifting instead of 0 to pi. We'll multiply that by 2 and add pi over 2 to that. So that will be 4 pi plus pi over 2. And you can get a common denominator multiplying by 2 over 2. 8 pi over 2 plus pi over 2 is 9 pi over 2. So now on our t-axis we have our first and fifth coordinates, and we can go ahead and get our third. We can do that by taking the average of the first and the fifth. So the third is going to be 9 pi over 2 plus pi over 2 all divided by 2. And in the numerator here you get 10 pi over 2. It kind of looks like a 16, so 10 pi over 2 divided by 2, and 10 pi over 2 is 5 pi, and so this ends up being 5 pi over 2. Then for the second coordinate, we average 1 and 3. So for the second coordinate, we get pi over 2 plus 5 pi over 2 divided by 2. So this is 5 pi over 2 plus pi over 2 is 6 pi over 2, which is 3 pi, all divided by 2. And then for the fourth coordinate, we'll go ahead and get the number between 3 and 5. So for the fourth coordinate here, we have the third coordinate, which is 5 pi over 2. We add the fifth coordinate, which is 9 pi over 2, and we divide by 2. That will give us 9 plus 5, which is 14 pi over 2 in the numerator, which is 7 pi, all divided by 2. We'll go ahead and put these on our graph, and we need a scaling, and so I think I'll choose this to be pi over 2. And the reasoning is because I need to go from pi over 2 to 9 pi over 2. So whatever scaling I make, I need to go to 9 pi over 2, and 9 pi over 2 is 9 of these units here, because, well, 9 pi over 2 is 9 times pi over 2. So let's see, we need to go from pi over 2 to, this would be 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7, 8, 9. So that there would be 9 pi over 2. Forgot to label my axes. I think I'll do that now. The third important t-coordinate is 5 pi over 2. So this is pi over 2, 2, 3, 4, 5. So 5 pi over 2. And then here is 3 pi over 2, which is my second coordinate, and my fourth coordinate is 7 pi over 2. Now remember, we're sketching the graph here of -2 sine of 1/2 t minus pi over 2 plus 1. And the main important piece of information here is that first, this is a sine function, so it's going to start at the midline. And second, there is a vertical reflection. So normally we would start at the midline here at the first important t value, and we would go up. But since there's a vertical reflection, we're going to go instead down to the bottom, and we'll go back to the middle, we'll go up top, and we'll go back to the midline. And we'll connect these with a curve that resembles the parent function, which is sine. Of course, we can also sketch our cosine graph. We don't need to repeat those same steps all over again. For -2 cosine 1/2 t minus pi over 2 plus 1. Now, two important things that you have to notice. This is the cosine graph, and there is in fact a vertical reflection. Normally for a cosine graph, you would start at the top line. However, since there's a vertical reflection, we'll start at the bottom. We'll go to the middle, and then we'll go up top, back to the midline, and back to the bottom. We'll connect these with a smooth curve that resembles the cosine function, and that would be its graph. Finally, let's go ahead and list some of those important characteristics that we defined earlier. So the amplitude, that is 2, because you simply take the vertical stretch, leave off any negative that's there. The midline, of course, we already found out, that's y equals 1. The period, you can find out two ways. The first way by doing the last minus the first, which would give you 8 pi over 2, which is 4 pi, or the way which doesn't require you to sketch the graph, which is by doing the old period divided by the number that's multiplying here, so divided by 1/2, and that would be the old period is the period of the parent function, 2 pi, divided by 1/2, which would be 4 pi again. So same answer, of course. If you didn't get the same answer, something went awry. And then finally, we have the phase shift, which is the horizontal shift. You just need to make sure to put negative if it's to the left. In this case, it's to the right. So the phase shift will be positive, and it is, well, the horizontal shift is pi over 2. So the phase shift is pi over 2.